Okay, we're looking at 4.3, example 2, more compositions of functions. So I just want to point out that on this g of x function, you might want to just use the property that says you can actually just make this 1/5 x. Might make it a little bit easier to do the rest of the problem. So let's write that one like that. We want to find f of g of x and then g of f of x. Okay, so that we'll do this one first. F of g of x. Now, in the previous example, what we were doing is plugging in numbers. Here, we're going to take the entire function. We're going to take that whole g function and plug it into the f function wherever we see an x. So I take the g function, which is this one here, and I'm going to insert it into the other function wherever I see an x. Okay? So that gives me -8 times the whole function here, 1/5 x plus 4. And then I still have the plus 9 on the end of that one. So then I have to simplify this. So we can distribute the 8, and we'll get -8/5 x minus 32, and then plus the 9 that's still there. So that gives us -8/5 x. And then minus 32 plus 9, what's that, 23, so -23. So there we go. There's the simplified version of f of g of x. Okay, now we'll do g of f of x, and we'll notice that function composition is not commutative. That means that we're not going to get the same answer when we reverse this like we do with multiplication or addition or something like that. So for g of f of x, we do the opposite. We take the f function, now that one, and we plug it in wherever we see the x on the other one. So that's going to give us 1/5 -8x plus 9, and then we still have the plus 4 on the end of that one. And then I'll have to simplify this, so I'll go ahead and distribute the 1/5, so we get -8/5 x, and if I distribute there, I get plus 9/5, and then plus 4. And if I write 4 as 20 over 5, then I can add these together and simplify it even more. So I get -8/5 x. If I write that again as 20 over 5, I get 29 over 5 for my most simplified answer.